Hello, hello, everybody. Welcome back. Oh boy, new day, a new something else. There's some miscreants in my chat asking me what's the live stream I give a shit about. Fuck up. More bots are enjoying this fucking thing, but you know, it's whatever. I guess it's to be expected, you know. Especially at the start. I don't have any like moderators or anything, so it's not like I have much of a choice in the matter right now. That being said, though, yeah, we're live on both channels, so we'll see how it goes. Okay, let me see here. What do I need to do before I quit out? Or not quit out, if I can start this thing. Do little things here and there. One moment. Taking little things here and there, sorry. Sorry about that. I know you want to get the show on the road. Take it one step at a time right now. Let's see here. Alrighty. Oh, I remember now. That's right. Let's go with this. Where are you? Apologies, everyone. Alright, that'd be good. God damn it, these fucking freaks. Get out of my chat. Sorry, everyone. I wish I didn't have to reopen Castrolab every single time I wanted to clear the chat. They really need to add like a thing to this to where it's a lot simpler. I'm certain there's other applications for this, but this is the one I have installed right now. I haven't had the time to look into any others recently, so apologies for that. But hey, I'm getting the interaction at least. I guess you could say that, you know. I'm getting engagement, you know. Probably an algorithm 1 or 2 notches, who knows? Probably not, I don't know. It's annoying, but fuck it. Let's see. Okay. So let me go ahead and turn this music down a bit so we can get started. There we go. Just so I can have a little bit of something in the background while we do this. I'll still be able to pay attention to what's happening. Go Gonna move that over there, of OBS there, and then open my thing. All right. Whoops. Hello, everybody. Hello. I got my camera fixed. Aren't you proud of me? I know I'm proud of me. And you know what? That's all that really matters. And, I think it got fixed. I had to fiddle around with it. It's a little off center, then that's why. I had to fuck around with it for a bit, so. Look over there. That should be pretty centered, I think. Alright. So we're gonna learn this stuff today. Just gonna... Oh boy. Let's see, it's gonna take a while, but hey. What we're here to do. Alright. Let's see here. Another scene. In overview of Godot's key concepts, we saw that a Godot game is a tree of scenes, that each scene is a tree of nodes. In this lesson, to explain a bit more about them, you'll also create your first scene. Nodes are the fundamental building blocks of your game. They are the ingredients in a recipe. Get this bowl off of my desk. Hold on a second. There we go. Send it over there. If you ever see dishes sitting on my bed right there, just know that they haven't been sitting there for a while. I usually just like fuck it's on my desk, get it out of my way. I set it there before I start every stream. So, anyways, we're straight. Okay, nodes are the fundamental building blocks of your game. This I know. They are like the ingredients in a recipe. There are dozens of kinds that can display an image, play a sound, represent a camera, and much more. All nodes have the following characteristics: a name, editable properties. There's two callbacks to update every frame. You can extend them with new properties and functions. You can add them to another node as a child. Yes, okay. The last characteristic is important. Together, nodes form a tree. It's a powerful feature to organize projects since different nodes have different functions. Combining them produces more complex behavior. As we saw before, you can build a playable character. The camera follows using a character to... Piss off! Cocksucker. God's sake! Whoa! I'm getting a lot of these at once. Holy moly. There's like 3 of them at once there. Oh my gosh. Good thing I was keeping an eye on my chat. Alright. There we go. Reset it. Ignore that. Alright. You can build a playable character. The camera follows using character body 2D node, a sprite 2D node, a camera 2D node, and a collision 2D collision shape 2D node. So yeah, okay. Nodes have different functions, combine these. Hold on a second. Hold on. Sorry about that. I had to take my mask off because the top of my head was really itchy. Anyways. I'm going to open it so we can play along. I'm going to... this, and then this. Should I send a tweet out? Ah, fuck it, I'll send a tweet out. Grab this. Go to Twitter. post something. Uh-oh, news. Yeah. Let me grab the links real quick. Bam, bam. Link address. I like showing off my my kick first and foremost on these. So hell yeah. Perfect. Like my own tweet. Get it at the algorithm. Whoops. There we go. Alright. And there we go. Close out of that. Whew. Okie dokie. That's done. I need to, oh my gosh, I need to stop looking at my stream, my own stream, because it's confusing my brain. I'm looking over there, I'm like, oh god. It's like, I see two mice on my screen, so I'm like, it confuses of which one's the real one. My brain is freaking out. Excuse me. Close this up. Holy Lord. Let's see, just fucking get rid of it. No. Test bench. There we go. There we have it. This. So we had the delete real quick. Me specifically the character body 2D, which we could just rename to character. Sprite 2D, clear shape 2D. And then camera 2D. Oops. Sprite 2D. There we go. Yeah. So this shape, I want to be a rectangle. Do that. And we do that. And then bam. This shape has been collisioned. So this is talking about something we did earlier. Let's see. I already did this. I don't think a lot of it clicked in all honesty. What was this? So why it say this is the we just did this? Because look, it says go to this. It says As we saw before, you can do this. Maybe this is just an example image and we have actually done this. Fuck off! Good lord, I swear. There we go. Alright, back to this. We organize nodes in a tree like our character. With this, we call this construct a scene. What save scenes work like new node types in the editor, where you can add them as a child of an existing node. In that case, the instance of the scene appears as a single node with the internals hidden. What? These work with new node types in the editor. Add them as a child of existing node. In that case, the instance of the scene appears as a single node. Internals hidden. Oh, you're talking about, okay, like this. I saw that before in one of the other things we were doing earlier. Not earlier, but in the past. Scenes allow you to structure your game however you want. You can compose nodes to create custom and complex node types. You can gain a character that runs and jumps, a life bar, a chest with which you can interact and more. The Go editor essentially is a scene editor. There's plenty of tools for editing 2D and 3D scenes, as well as user interfaces. 2D and 3D scenes. Yeah, okay. Your project can contain as many of these scenes as you need. The engine only requires one as your application's main scene. The scene Godot will first load when you or a player runs the game. No. Piss off. I hate this. Try to scrape my ire, apparently. On top of acting like nodes, scenes have the following characteristics. They also have one root node, like the player for it, in our example. You can save them to your local drive and load them later. You can create as many instances of a scene as you like. You can have 5 or 10 characters in your game created from your character scene. Let's create our first scene with a single node. Alright. Let me update this again. I say sure about this because my channel didn't update on my YouTube. There we go. I fixed it. Now on here. Yeah. We good. Alright. Okay. On top of acting like nodes, scenes have the following characteristics. They also always have one root node. Like the player in our example. Oh wait, I already read that. Sorry. As soon as you like, you could just in your game created from your character scene. Yeah. Let's create our first scene with a single node. To do so, we create a new project first. After opening the project, you should see an empty editor. An empty scene. The scene dock on the left shows several options to add a root node quickly. 2D scene adds a 2D node, 3D scene adds a 3D node, and user interface adds a control node. These present these presets are here for convenience. They are not mandatory. Other nodes, a node, oh, what? Yeah, other nodes let you select any node to be the root node. And an empty scene other node is equivalent to pressing the add child node button at the top left of the scene dock, which usually adds a new node as a child to the currently selected node. Okay, there you go. We're going to add a single label node to our scene. Its function is to draw text on the screen. Press the add child node or other node to create a root node. A root node. I just get rid of all this. Hey, that worked. If I did the parent one, I removed everything. You said I need a label. There we have it. Show you the lowest available nodes. Nope. You get the fuck out of here. Select the label node. You can type its name to filter down the list. There you are. Select. Good. Why do I keep yelling? What the fuck? Label node. To select it, and click the create button at the bottom of the window. Okay. What happens when you add a scene's first node? Scene changes to the 2D workspace because label is a 2D node type. So appears selected top left corner of the viewport. The node appears in the scene dock on the top left. And those properties appear in the inspector dock on the right. Okay. Kushida justify. Fuck is Kushida? I had that on one. Did not. Oh yeah, I do. Kushida justification. The fuck is Kushida justification? I don't know what that means. Changing those properties. The next step is to change the label's text property. Let's change it to hello world. Oh my gosh, they said the thing. Where is it? Hello world. Smiley face. There you go. Next step is to change the label's text property. Let's change it to hello world. I already did that. You'll see the text draw in the viewport as you type. Okay. You can move the note, so you can edit any property listed in the inspector as we did with the text. For a complete reference of the inspector doc, see the inspector doc. Okay. You can move your label node in the viewport by selecting the move tool in the toolbox. Okay. A little selected, click and drag anywhere in the viewport to move it to the center of the view delimited by the rectangle. Okay, I'm gonna do this. This. Okay, there. How beautiful. Everything's ready to run the scene. Just run current scene button at the top right of the screen, or press S6 command plus R on macOS. Okay. Specific scene or just run scene. Wait on. One classifies as run. That's F5. This one's F6. Application which is required to run it. Click the save button in the file browser to save it as label.tscn. Got the save. Other file. Oh, it's an editor. Only allows you to save files inside the project. The RES path at the top of the window represents the project's root directory and stands for resource path. For more information about the file paths in Godot's file system, the application should open in a new window and display text hello world. Alrighty. Looky there, look at that award-winning smile. How beautiful. Let's take a screenshot of that. Beautiful. Beautiful. Alright. Have to go back here. Looky there. Close the window or press F8. I'm actually going to do that real quick. F8. Okay. To run our test scene, we use the run current scene button. The button next to it, run project, allows you to set and run the project's main scene. You also press F5 command plus B on macOS to do so. Alrighty. Pop window appears to invite you to select the main scene. Click the select button and then the file dialog that appears, double click on label.tscn. Okay. So, bam. Hell yeah. Oh, that's weird. You see this? When I move up and down, it's like, I don't know how to frame it for that, but like, up and down, it's like snapping to certain points. It's not actually, it's not like smoothly attaching to it. I don't know how visible that is on your end, but it's weird. Bring that back up. Sorry about that. Sorry to flashback you there. Dash run again. Moving forward, every time you run the project, Godot will use this scene as a starting point. Okay. In the next part, we will discuss another key concept. Oh my goodness gracious. In games and in Godot, creating instances for a scene. Okay. Creating instances. This sort refers to instancing scenes in the editor. So how to instance scenes from code. See nodes and scene instances. Godot's approach to instancing described below should not be confused with hardware instancing. They are used to render large amounts of similar objects quickly. See optimization using multi-meshes instead. In the previous part, we saw that a scene is a collection of nodes organized in a tree structure with a single... Oh my gosh, hold on. Give me a second. Whoa. I apologize for how I'm acting today. I'm a little tired, but I'm trying to get this in my head at the same time. Excuse me. In the previous part, we saw that a scene is a collection of nodes organized in a tree structure with a single node as its root. You can split your project into any number of scenes. This feature helps you break down and organize your game different components. You can create as many scenes as you'd like and save them as files with the .tscn extension, which stands for text scene. Level.tscn file from the previous lesson was an example. Call those packed scenes, as they pack information about your scene's content. Okay. Here's an example of a ball. It's composed of a rig body 2D node as its root named ball, which allows the ball to fall and bounce on walls. A straight 2D and a clear straight 2D. Once you have saved a scene, it works like a blueprint. You can reproduce it in other scenes as many times as you like, replicating an object from a template like this is called instancing. As I mentioned in the previous part, instance scenes behave like a node. The editor hides their content by default when you instance the ball. You'll only see the ball node. Notice how each duplicate has a unique name. Every instance of the ball scene starts with the same structure and properties as ball.tscn. Jeez, what is going on with me today? The ball scene starts with the same structure and properties as ball.tscn. However, you can modify each independently, such as changing how they bounce, how heavy they are, or any property exposed by the source scene. Okay, in practice, let's use instancing in practice to see how it works together. We invite you to download the ball's sample project we prepared for you, instancing starter.zip. One moment, please. At the archive on your computer to import, you need the project manager. The project manager is accessed. Oh, sorry. Damn you! Caught me while my back was turned. My pants were down. And I was bent over. And you know, I dropped the soap and just the fuck out of chat. Anyways, and I was oiled up. Practice, let's use fuck. Hold on. Sorry. Practice, let's use to import you need the project manager. That's just, or if you've already have to open, click on project, quit to project list. The project manager, click import button on the import. Wait, to import the project. Excuse me. Okay, so fuck. I thought it was open up here. It's not. Project. Click the project list. Yes. And hope that saved. If it didn't, fuck. Well, I guess it doesn't really matter that much. It wasn't like it was anything particularly special or important. Yeah, I don't want to use Discord overlay. Fuck off. Documents. F. The fuck was even over there? No, I don't want any of that. Go assets. Yeah, there it is. The pop-up that appears. The folder you extracted. Double click the project.gdo file to open it. Okay. If I click the import button. Would it notify you that the project was last opened in an older Godot version may appear? That's not an issue. Click OK to open the project. Okay. The project contains two packed scenes. Main.tscn containing walls against which the balls collide, and ball.tscn. The main scene should open automatically. If you're seeing an empty 3D scene instead of the main scene, click the 2D button at the top of the screen. Which just happened to me? Holy shit! What do you know? What do you know about that? Let's add a ball as a child of the main node. In the scene dock, select the main node, then click the link icon at the top of the scene dock. This button allows you to add an instance of a scene as a child of the currently selected node. Okay. PSN. Double click the to instance it. The ball appears in the top left corner of the viewport. Click on it and drag it towards the center of the view. Play the game by pressing F5. Should see it fall. And then F5. Hell yeah. Ah. Now we want to create more instances of the ball node. The ball is still selected. Press Control D and D on the macOS to call duplicate command. Click and drag to move the new ball to a different location. There we go. You can repeat this process until you have several in the scene. But yeah, again, you should now see every ball fall independently from one another. This is what instances do. Each is an independent reproduction of a template scene. Alrighty. There we go. Yay. There is more to instances. With the feature, you can change the properties of one ball without affecting the others using the inspector. Change the default properties of every ball by opening the ball.tscn scene Make a change to the ball node there. Upon saving, all instances of the ball in the project will see their values update. Let's try this. Double click, pull out TSCN in the file system, open it. In the scene dock on the left, select the ball node. Then in the inspector on the right, click on the physics material property to expand it. Okay. Where did I find this at? Oh, ball TSN. Okay, I can do that there. Okay. Ball node. What's it saying? In the scene dock on the left, select the ball node. Switch on the right, click on the physics material property, expand it. No, you don't. Yeah. I don't actually see that. Oh, there it is. Hold on. It says mount property to 0.5. There we go. And press enter. Play the game pressing F5. Hell yeah. Significantly bouncier. I don't know if they're ever gonna stop bouncing. All right. So the balls now bounce a lot more, as the ball scene is a template for all instances. Modifying it and saving causes all instances to update accordingly. Let's now adjust an individual instance. Head back to the main scene by clicking on the corresponding tab above the viewport. The instance ball nodes. Inspector and set its gravity scale value to 10. A gray revert button appears next to the adjusted property. This icon indicates you are overwriting a value from the source packed scene. Even if you modify the property in the original scene, value override will be preserved in the instance. Clicking the revert icon will store the property to the value in the saved scene. Rerun the game and notice how the ball now falls much faster than the others. Yeah. I'll go back here, click this. Now I'm going to set this one's. What was it I was changing? Gravity scale. Let's go back over here. Set this to 1. Look at that again. Oh yeah. And I set this to say let's do -1. That's funny. There goes that one. I was wondering if it did the exact same thing or not. I didn't know if it was gonna be like a chaotic thing where only some like was kind of inconsistent. There we go. Alright, so now if I play this, there we go. I noticed that it saves the changes once I actually play the scene, just automatically. Again. Okay, yeah. You notice you were unable to change the values of the physics material of the ball. This is because physics material is a resource and needs to be made unique before it can edit before wait, what? It needs to be made unique before you can edit it in a scene that's linking to its original scene. To make a resource unique for one instance, right click on the physics material program, the inspector, and click make unique in the context menu. Make unique in the context. Well, let me oh, it's saying I can't change this until I make it unique. Okay. Whoops. Did the wrong thing. Oh, I can just click it and it relaunches it. I have to close that every time. I didn't realize that. Where were we? Alright. See, this is a design language. Instances and scenes in Godot offer an excellent design language, setting the engine apart from others out there. We designed Godot around this concept from the ground up. We recommend dismissing architectural code patterns when making games with Godot, such as model view controller, or entity relationship diagrams. They start by imagining elements players will see in your game and structure your code around them. I had no idea what that fucking meant. For example, you can break down a shooter game like so. Stage. Airship weapon. Code. Stage. You can come up with a diagram like this for almost any type of game. Each rectangle represents an entity that's visible in the game from the player's perspective. The arrow points towards the instantiator of each scene. Once you have a diagram, we recommend creating a scene for each element listed in to develop your game. You'll use instancing either by code or directly in the editor to build your tree of scenes. Programmers tend to spend a lot of time designing abstract architectures and trying to fit components into it. Designing based on scenes makes development faster and more straightforward, allowing you to focus on the game logic itself, because most game components map directly to a scene. Using a design based on scene instantiations means you need little other architectural code. I pretend I understood a word that thing just said to me. Here's the example of a scene diagram for an open world game with tons of assets and nestled elements. Table, room, house, citadel. Seat, church. Bench, terrain. Wood, player, terrain. Imagine we started by creating the room. We could make a couple of different room scenes with unique arrangements of furniture in them. Later, we can make a house scene that uses multiple room instances for the interior. Create a citadel out of many instanced houses and large terrain on which we could place the citadel. Each of these let's see. Create some scenes representing. Sorry, I got lost. The furniture. Later, we can make a house scene that uses multiple room instances. The interior, we can create a citadel out of many instanced houses and a large terrain on which we could place the citadel. Each of these would be a scene instancing one or more subscenes. Later, we can create scenes representing guards and add them to the citadel. But that would be indirectly added to the overall game world. We could do. It's easy to iterate on the your game like this, as all you need to do is create and instantiate more scenes. More scenes. We designed the editor to be accessible to programmers, designers, and artists alike. A typical team development process can involve 2D or 3D artists, level designers, game designers, and animators, all working with the Godot editor. Summary: instancing, the process of producing an object from a blueprint, has many handy uses. The scenes, it gives you the ability to divide your game into reusable components, a tool to structure and encapsulate complex systems, a language to think about your game project's structure in a natural way. Alright. Content has not been up to 4.5, maybe updated. Okay. Surprised they haven't updated this to 4.5 yet. How long ago did 4.5 come out? September 15th. That's it's almost 2 months ago at this point. Right? I'll look at something real quick. Hold on 1 second. I'll be right back. Nope. I'm back. Sorry, I had to check something. Yeah, 4.5. That was almost 2 months ago. In case you're wondering what I was checking, I had to make sure that today should have been board meeting number 3. I couldn't remember which one we were on. But yeah, it's been a couple months now. Surprised it hasn't been updated or anything yet. Dude, I'm gonna fucking report this freak if he keeps messaging in my fucking chat. Like the original account, because he keeps sending bots over and over and over into my fucking chat. Well, I'm gonna look at something real quick.
I shouldn't say that.
I'll deal with that later. Fuck. I just get on my fucking nerves. Well, it's not like I'm getting furious or anything. It's just I hate having to fucking reset my chat every fucking time one of those fucking bots pop up. It's really annoying. Back to what I was saying. Is this on this monitor? It should be over here. There we go. This is a webinar review of the available scripting languages in Godot. You'll learn the pros and cons of each option. As part, you'll write your first script using GDScript. Scripts attach to a node and extend its behavior. This means that scripts inherit all functions and properties of the node they attach to. For instance, take a game where a camera 2D node follows a ship. I'm sorry, let's look at the GIF below. The camera 2D node follows its parent by default. Imagine you want the camera to shake when the player takes damage. As this feature is not built into Godot, you would attach a script to the camera 2 node and control the shake. Available scripting languages. Godot offers 4 gameplay programming languages: GDScript, C# and via HGD extension technology, C and C++. There are more community support languages, but these are the official ones. You can use multiple languages in a single project. For instance, in a team, you can code gameplay logic in GDScript as it's fast to write. Use C# or C++ to implement complex algorithms and maximize their performance. Or you can write everything in GDScript or C# into your call. We provide this flexibility to answer the needs for game projects and developers. Which language should I use? We recommend starting with GDScript, which is what I plan on using. We use language specifically for Godot and the needs of game developers. It has a lightweight and straightforward syntax and provides the tightest integration with Godot. For C#, you will need an external code editor like VS Code. You will need an external code editor like VS Code or Visual Studio. While C# support is now mature, you will find fewer learning resources compared to GDScript. That's why I recommend C# mainly to users who already have experience with the language. Let's look at each language's features as well as its pros and cons. GDScript. GDScript is an object-oriented and imperative programming language built for Godot. It's made by and for game developers to save you time coding games. Its features include a simple syntax that leads to short files, blazing fast compilation and loading times, tight editor integration with code completion for nodes, signals, and more information from the scene it's attached to, built-in vector and transform types, making it efficient for heavy use of algebra, a must for games. Okay. Supports multiple threads as efficiently as statically typed languages. No garbage collection, as this feature eventually gets in the way when creating games. The engine counts references and manages the memory for you in most cases by default, but you can also control memory if you need to. Gradual typing. Variables have dynamic types by default. You can also use this type. Variables have dynamic types by default, but you can also use type hints for strong type checks. GDScript looks like Python as you structure your code blocks using indentations, but it doesn't work the same way in practice. It's inspired by multiple languages, including Squirrel, Lua, and Python. Don't know what the fuck Squirrel is, but you know. Why don't we use Python or Lua directly? Years ago, Godot used Python, then Lua. Both languages integration took a lot of work and had severe limitations. For example, threading support was a big challenge with Python. Developing a dedicated language doesn't take us more work, and we can tailor it to game developers' needs. We're now working on performance optimizations and features that would be difficult to offer with third-party languages. Microsoft C# is a favorite amongst game developers. We officially support it. C# is a mature and flexible language with tons of libraries written for it. We were able to add support for it thanks to a generous donation from Microsoft. Hot dog. I didn't even know they got a donation from Microsoft. That's pretty fucking awesome, actually. G# offers a good trade-off between performance and ease of use, although you should be aware of its garbage collector. Ease of use. You must use the .NET edition of the Godot Error to script in C#. You can download it on the you can download it on the Godot website's download page. Yeah. Since Godot uses .NET 8 in theory, you can use a third-party .NET library or framework in Godot, as well as any common language infrastructure compliant programming language, such as F#, Boo, or Clojure CLR. However, C# is the only officially supported .NET option. GScript code itself doesn't execute as fast as compiled C# or C++. However, most script code calls functions written most script code calls functions written with fast algorithms C++ code inside the engine. In many cases, running gameplay logic in GScript, C# or C++ won't have a significant impact on performance. That's pretty good, at least. Attention! Projects written in C# using Godot 4 currently cannot be exported to the web platform. Use C# on that platform. Consider Godot 3 instead. Android and iOS platforms support these available as of Godot 4.2, but is experimental and some limitations apply. C++ GD extension. The extension allows you to write game code in C++ without needing to recompile Godot. I saw that you could get Godot on your phone, which was really weird to look at. I saw it. I even like had it installed before. Let me see if I can figure this out. I don't know if you need an APK or if you just get it straight from the fucking web store. Yeah, you can just get it on your phone. Like straight up. Yeah, look at this shit. Oh, let me open this up on here. Yeah, look at this. I don't know if you can see it well or anything, but
excited because I'm an
see it right there. In the top left. Kinda, not really. It's not wanting to focus, but anyways, yeah. They have Godot on mobile, and you can just fucking, you can start a project. Yeah, look at that. Is that fucking weird? Oh, let me. Ooh. I'm mirrored here, so I'm having a hard time figuring out what's. Whoa. But yeah, that's insane. That's just a thing on here. That's so fucking weird. They just have an app. They do it on their phone. It's insanity. I know my Ty doesn't show up super often in these streams, does it? I'm proud of my Ty. I learned to do it specifically for this too. GD extension allows you to write. Anyways, back to this. Sorry. GD extension allows you to write game code in C++ without needing to recompile Godot. Excuse me. You can use any version of the language or mix compiler brands and versions for the generated shared libraries. Thanks to or use of JavaC API bridge. I don't think that English right, unless I just read that completely wrong. G extension is the best choice for performance. You don't need to use it throughout an entire game, as you can write other parts of GDScript or C#. That's neat. When working with GD extension, the available types, functions, and properties closely resemble Godot's actual C++ API. Summary: scripts are files containing code that you attach to a node to extend its functionality. Okay. It supports 4 official programming languages, offering you flexibility between performance and ease of use. You can mix languages, for instance, to implement demanding algorithms with C or C++. Alright, most of the game logic with GDScript or C#. Create your first script. Alright. As I said, you will code your first script to make the Godot icon turn to circles. So we mentioned in the introduction, we assume you have programming foundations. Well, this tutorial is written for GDScript, and the equivalent C# code is included in another tab of each code block for convenience. Project setup. Please create a new project to start with a clean slate. Fine. Project. Your project should contain one picture of the Godot icon, which we often use for prototyping in the community. We need to create a Sprite 2D node to display it in the game. Alright, new. Tate. That's a completely wrong file, but I don't care enough to fucking correct it. As you're remotely the right file path. But I'm probably just gonna delete this after we're done anyways. So. Ooh. I check the we are on the music. No, we've got a good ways to go. Let's see. Please create a new project to start with a clean slate. Your project should contain one picture icon. We need to create a Sprite 2D node to display it in the game. In the scene dock, click the other node button. Type Sprite 2D in the search bar to filter nodes, and double click on Sprite 2D to create the node. Your scene tag should now only have a Sprite 2D node. Set the editor for that, and I didn't have to double click it. A Sprite 2D node needs a texture display. In the inspector on the right, you can see the texture property says empty. To display the Godot icon, click and drag the icon.svg for the file system dock onto the texture slot. Note, you can create Sprite 2D nodes automatically by dragging and dropping images on the viewport. Sick. Neat. There we go. to this. Then click and drag the icon in the viewport to center it at the gate view. Create a new script. To create and attach a new script to our node, right-click the Sprite 2D in the scene dock and select Attach Script. Attach node script window appears, allows you to select the script's language and file path among other options. Change the template field from node default to object entity. To start with the clean file, leave the other options set their default values and click create button to create the script. Okay. All right. C# script names need to match the class name. In this case, you should name the file mysprite2d.cs. The script workspace should appear in your new sprite_2d.gd file. Open and the following line of code. Yeah. Extends Sprite2D. Our GD script file is implicitly a class. The extends keyword defines the class this script inherits or extends. In this case, it's Sprite2D, meaning our script will get access to all the properties and functions of the Sprite2D node, including classes that extends like node, 2D, canvas, items, and node. Keyword defines the class. Our script will. Sprite2D meaning our script will get access to all the properties and functions of the Sprite2D node. The classes extends like node, 2D, canvas, item, and node. In GD script, you omit the line with the extends keyword. Your class will implicitly extend the first kata, which Godot uses to manage your application's memory. Okay, never mind. Inherited properties include the ones you can see in the inspector dock, like our node texture and our node's texture. Okay. And by default, the inspector displays by default, the inspector displays a node's properties in title case with capital words separated by a space. In GDScript code, these properties are in a snake case, which is lowercase words separated by an underscore. You can hover for any properties named in the inspector to see a description and its identifier in the code. Okay, I see what you're saying now. Property frame chords. Okay. This actually helps me figure out some things. This may not be a reference for absolutely everything I can do with it, but it does help me understand some of the things I can do with it. Such as editing the description, the editor's description. I'll translate. This is interpolation mode. But yeah, anyways, you get the idea. Let's see, what do you need me to do next? Well, our script currently doesn't do anything. Let's make it print the text hello world to the output bottom panel to get started. Add the following code to your script. Oops. Init print hello world. Goes init. The fuck keyword defines a new function named init. This is a special name for our class. It is constructor. It should cause init on every object or node upon creating it to memory if you define this function. Say this scene as sprite underscore 2D PSCN because there's the tab at the start of the line. This print is necessary for the code to work. You omit it or don't indent a line correctly, the editor will highlight it in red and display the following error message. Indented block expected. This scene as sprite underscore 2D.tscn if you haven't already. Then press S6 to run it. Look at the output bottom panel that expands. It should say hello world. Okay, wonderful. Call the object script is instantiated after the object is initialized in memory through object.new in GDScript. Stay C#. Similar to constructor and most programming languages. If init. I still have absolutely no idea what any of that means. I just hit S6. Looky there. Looky there, baby. So wonderful. Whoops. It was a misinput. Calm down. You calm the fuck down. Yeah. Well, turning around. It's time to make our node move and rotate. To do so, go to add 2. I'm going to lose my fucking mind. I don't know why I keep yawning. It's time to make our node move and rotate. To do so, we're going to add two member variables to our script. Check this out. The movement speed in pixels per second and the angular speed in radians per second. Add the following after the extends right 2D line. Variable speed 400, variable angular speed pi. Yeah. Don't do that at all. Snap. Okay. We'll do a little more. Our variables sit near the top of the script. After any extends line, but before functions. Every node instance within the script attached to it will have its own copy of the speed and angular speed properties. It's a good deal for ingredients by default, but have built-in functions are as available if you prefer to calculate angles and degrees instead. One moment. Well, never mind. I felt like I had to sneeze, but apparently I don't. Shit. Okay. To move our icon, we need to update its position and rotation every frame in the game loop. We can use underscore process virtual function of the node class. Define it. Any class that extends the node class. XY2D Godot will call the function every frame and pass it an argument named delta, the time elapsed since the last frame. No, games work by rendering many images per second, each called a frame, and they do so in a loop. We measure the rate at which the game produces images frames per second FPS. Most games aim for 60 FPS, although you might find figures like 30 FPS on slower mobile devices or 90 to 240 virtual reality games. The engine and game developers do their best to update the game world and images at a constant time interval, so there are always small variations in frame render times. That's why the engine provides us with their delta time value, making our motion independent of our frame rate. Define the function func process delta rotation plus equals angular speed times delta. Okay. Hold on. There we go. Okay, the hot keyword. I defines a new function. After it, we have to write the function's name and arguments it takes in parentheses. Colon ends the definition and the indented block that follow. I'm gonna go insane. No, I need to go insane if I don't stop yawning. A colon ends the definition and the indented block that follows are the function's content or instructions. Notice how underscore process is the function arguments it takes. Yeah. We can forget. And the indented block that follows are the function's content or instructions. Notice how process like init starts with a leading underscore. By convention, Godot's virtual functions, let's say built-in functions you can override to communicate with the engine, start with an underscore. The line inside the function rotation plus equals angular speed times delta increments r spreads rotation every frame. Here, rotation is a property inherited from the class node 2D, which sprite 2D extends. It controls the rotation of our node and works with radians. In encoder, you can control plus click on any built-in property or function like position, rotation, or process of the corresponding documentation in a new tab. The icon turn in place. You can override. The line inside the right here. Sorry. This is a property here for the class node2D, which node2D is trying to. Sorry about that. I just have to reread stuff in order for it to sink in. Because I read the first time and my brain doesn't even process what I just read. In C#, notice how the delta argument taken by underscore process is a double. We therefore need to convert it to float when we apply it to the rotation. Yeah, well. Yay! Move forward. Let's now make the node move. Add the following two lines inside the process function, ensuring the new lines are indented the same way as rotation plus equals angular speed times delta in line before them. Variable velocity equals vector two dot up rotation times speed. Position plus equals velocity times delta. So that was our velocity equals 2 dot up dot rotated rotation times speed. Position plus equals... What the fuck? Damn it, what the fuck? I generally can't go down. What now? How about this? Oh wait, hold on, maybe. No, I don't know. Yeah, no, I didn't fix that. Position plus equals velocity. Velocity. Delta. Oh. I guess I'll just continue. I tried to look for a solution to that, but I can't find one. Let's see if it doesn't just work. Yeah, what the fuck? Alright, what am I missing here? Nothing. Where's position? When it's a toggle script, it defines a property of the class inside a function and defines what exists within the function scope. Then velocity. the vector representing both direction and speed to make the node move forward. We start from the vector 2 classes constant vector 2 dot up, a vector pointing up, rotated by the vector 2 method rotated. Push vector 2 dot up dot rotated. Rotation is a vector pointing forward relative to our icon. Multiply by our speed property and gives us a velocity we can use to move the node forward. We add velocity times delta to the node's position. To move it. The position itself is of the type vector 2, a built-in type in Godot representing a 2D vector. Alpha arises. Important. There. Huh. So this one says this one's up to date. Why can't I find this? Why can't it find this? Well, what if I... Let's see. Up. What if I do this? Okay, I need to put it in that. That's why it was fucking up. Freaking out. Yeah. Figured it out. Oh. times 2. We got a 0 there. Whee! Yeah, baby. Just as is. This. There we go. Should move this over a bit. Loading screen icon. Let's go. I don't know what the fuck I'm doing. Close out of that. Alright, that's here. Blah 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 blah. Moving a node like that does not take into account colliding with walls or the floor. In your first 2D game, you'll learn another approach to moving objects while detecting collisions. Our node currently moves by itself. In the next part, listening to player input, we'll use player input to control it. Complete script. Here's the complete script. I should have checked down here. Alright. That was a good run, everybody. Sure. Let's see here. Listening to player input should be next. And you know what? I think we did pretty good so far. Good 2 hours of learning this stuff. Well, it was a 2-hour stream. Exactly 2 hours of learning this stuff. We had some. We got tried to load it by other little things here and there, but you know, overall, I'll keep this ready for tomorrow. And there's one thing that's like that bothers me. Let's see if I can find it. Or I can't really find out at the top of my head. Hold on. There's something like it was saying that we expect you to already have a understanding of this stuff somewhere in there. Can't find it right now, but I think it's just something like that. And I don't really have much of a grasp or understanding of this stuff, but I think if I keep this up, I may. It may just be better if I do learn something else first, but I'll look into that more to make sure before I continue and like back myself up into another wall. So I'm going to yeah, I'm going to do listening to player input tomorrow. So which is what I intend to do with these board meetings, but as you can imagine, I don't really have anyone to watch or talk to on these. So right now I'm kind of stuck in this, just doing stuff during our board meetings instead of actually getting feedback from people and showing off what I've done. I haven't really had much to show off, like what I've done this week with the stuff. Usually I'd have some stuff to show off, be like, hey guys, I did this, 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 and this. I haven't this week because it's been a really busy week for me. Not just with this stuff. Like yesterday, the camera malfunctioned, which working now, great. Family things happened these past few days. I wasn't able to stream 2 of the days this week, which sucked. And then 2 of those days I had to play Spyro because I had already told my friend I was going to. So board meetings are supposed to be show off what I've done so far and get opinions from people as to the direction I should be going in. But as you can imagine, I don't have anyone to talk to. So, right now, especially this week, I haven't been able to use it for that. But I intend to eventually be able to use it for that in a more permanent sense. I just need to get people talking, but that's probably not gonna happen until I get something a project actually working. I imagine that people are gonna be interested in watching this until I actually know what I'm doing. But that's not the fun. It's part of the charm, my opinion. I think it's part of the charm. But right now, we're just figuring things out. But yeah, tomorrow I'll be back in once again to try and do this next part of this listening to player input and continue on from there. We may get to the probably get to the first 2D game tomorrow. Not sure, but I need to look into some things and see if this is the correct direction for us to go moving forward. I don't know if I need to probably learn something else first and then work on this or what, but you know, in the meantime, we're just sticking with this. So I'll keep you all updated tomorrow. I'll message you on Twitter if anything happens. Same old. But yeah, that's it for me tonight. Good night, everybody. I hope you have a wonderful rest of your night. Bye. Bye.